Hey there, and welcome. Sometimes the most delightful little questions can lead us to some seriously powerful ideas. Today, we're going to use a story about a bunch of adorable guppy babies to unlock a really brilliant mathematical tool, one that helps us count things that seem, well, almost impossible to count. Let's dive in and see how a simple fish story can change the way we see complex problems. So our journey is going to kick off with a puzzle. On the surface, it seems pretty straightforward, but stick with me here, because the solution reveals this surprisingly elegant way of thinking that you can actually apply to all sorts of problems. Okay, so meet Fred. He's got 15 identical guppy babies and 4 empty fish bowls. But here's the catch. There's a rule. Every single bowl has to have at least 2 guppies in it. So the big question is, how many different ways can Fred arrange his fish without breaking that rule? Now, your first instinct, like mine, might be to just start listing out the options, right? You could say, okay, bowl 1 gets 2, bowl 2 gets 2, bowl 3 gets 2, that leaves 9 for the last bowl. That works, cool. What about 3, 3, 3, and 6? That works too. But you can already feel how this gets super messy, really fast. It's so easy to miss a combination or count the same one twice. We don't need a messy list. We need a system. The real solution comes from a simple but kind of profound change in perspective. The secret isn't to focus on the bowls at all. The secret is to focus on the fish. First things first, let's just get that big, annoying rule out of the way. We know we need at least 2 fish in each of the 4 bowls, so let's just do that. Boom, 2 fish in each bowl. That's 8 fish taken care of. Now the problem is so much simpler. We just have 7 free fish left to distribute any way we want. And here it is. This is the crucial step, the big aha moment. The trick is to completely forget about the bowls. Seriously. Instead, just picture those 7 remaining fish all lined up in a row. All of a sudden, this isn't a problem of filling containers anymore. It's a problem of arranging items on a line. This is the key visual shift that unlocks the whole thing. So if we've forgotten the bowls, how do we make our 4 groups? Well, we use dividers. Imagine just placing dividers or bars somewhere in that line of fish. Now think about it. To create 4 distinct groups, we actually only need 3 dividers, right? 1 divider splits the line into 2 groups, 2 dividers make 3 groups, so 3 dividers make the 4 groups we need. This simple idea, trading bowls for dividers, is what allows us to jump from a messy, real-world situation into the clean, elegant world of mathematics. Let's see how this little visual trick turns into an incredibly powerful formula. So what we've actually done is we've completely transformed the problem. We're not thinking about fish and bowls anymore. We're now thinking about arranging symbols. We have our 7 fish, which we're going to call stars, and our 3 dividers, which we'll call bars. The problem is now totally different. It's simply, we have 10 empty slots in a row, and we just need to decide which 3 of those slots will be our bars. So, after all that, after this whole shift in thinking, how many different ways can Fred actually arrange his guppies? The answer is 120, a nice, clean number. Now, let's quickly look at the math that got us there. The math behind this is a concept from Combinatorics called a combination. We've got 10 total spots, and we need to choose 3 of them for our bars. For the first bar, we have 10 choices. For the second, 9 choices left. For the third, 8. But wait, since the bars are all identical, the order we pick the spots in doesn't matter. So to fix that, we have to divide by the number of ways you can arrange 3 things, which is 3 times 2 times 1. And that calculation is what gives us our final answer of 120. And just to prove this isn't some abstract math trick, let's connect it right back to the fish. Here's one of those 120 possible arrangements. We have bowls with 2, 3, 2, and 8 guppies. Add those up, you get 15. And is every bowl has at least 2? Yep, our method works perfectly. We can actually boil this whole method down to a simple 4-step recipe. Step 1, handle the minimums. Just get the rules out of the way first. Step 2, count what's left over. Those are your stars. Step 3, figure out your dividers. And remember, it's always 1 less than the number of groups. And finally, step 4, calculate the combination. How many ways can you place your bars among all your items? All right, now that you have the recipe, the absolute best way to really understand it is to use it yourself. So let's put you in the driver's seat with a new puzzle. So, are you ready to put that recipe to the test? Okay, so let's meet Maya. She's got 19 guppies and 5 bowls, and the same rule applies, at least 2 guppies per bowl. This is a great time to pause, grab a piece of paper, and try applying that 4-step recipe yourself. See if you can figure out the answer. All right, let's walk through it. Step 1, pre-fill the bowls. 5 bowls with 2 fish each uses up 10 fish. That leaves 9 extra fish to arrange. So those are our 9 stars. Step 2, we need dividers. For 5 bowls, we need 4 dividers or bars. That gives us 13 total items to arrange. 9 stars and 4 bars. The problem is simply 13 choose 4. See? It's the exact same logic, just with slightly different numbers.
The reason this is so cool and so powerful is that, honestly, it's about way more than just counting fish. This is about a fundamental problem-solving technique called abstraction.
The real magic here is turning a messy physical problem, arranging actual fish in actual bowls, into a clean, abstract problem of just arranging symbols. The stars and bars method is the bridge that lets us make that leap, turning all that real-world complexity into a simple, solvable equation. And this isn't just some clever math puzzle, I promise. This exact same stars and bars logic is used in some incredibly important fields. Computer scientists use it to figure out how to efficiently distribute data across servers. Physicists use a version of it to model how energy particles can be arranged. And in business, it can help figure out the best way to allocate resources to different projects. It really is a fundamental concept. So really, the big takeaway today isn't a formula. It's a question for you. What messy problems in your own life or work could be solved not by just trying harder, but by changing your perspective and looking for that simple, elegant pattern hidden just beneath the surface? Thanks for joining me.